Alrighty, so we are going to bring together everything that we've been learning about conic sections into this one review. Okay, so our first step is to write the equation in graphing form and determine what kind of conic it is. So remember, our four types of conics are circles, ellipse, hyperbola, and parabola. So, in our equations, this will be a little cheat sheet for you. So the easiest one to figure out if you're looking at the equation is parabola, because it only has one squared variable. So that's right away, if you see that, you know that is going to be a parabola. Now, the next easiest one is hyperbola, because you'll have both variables squared. And then the next thing is you'll have a subtraction in there. Okay? Now, ellipse and circles, they're very similar. You'll have both variables squared for both of them. But the one difference is circles have same coefficient. I'm going to write that where you can see it. And ellipses will have different coefficients. And when I say coefficients, I mean the number that's being multiplied in front of the x squared and y squared. So in a circle, if I'll write a little example here, that would be like 2x squared plus 2y squared equals 1. That would be an example of a circle. For an ellipse, it would be 3x squared plus y squared equals 4. So notice how coefficients are different. Then that's an ellipse. Okay, so that's a little cheat sheet to help us determine what kind of conic it is. So, and another way to do that is to write it in graphing form and then look at the standard form and then go from there. So, if we're looking at this first one, it has 3 and 3, the coefficients are the same. That would make it a circle. So, in order to get this in standard form, we need to get rid of these 3's. Remember, for a circle, we can't have a coefficient in front of our x squared and y squared. So we divide both sides by 3, and we would get x squared plus y squared equals 9. Now, what I want you to do here is find all of the important things in a circle, so the center and the radius, and graph it on your graph here, and press pause, do that, and then check your work, and I'll write it all on the side. Okay, so pause the video and show your work. Okay, so your circle should look something like this. Center at 0, 0. Your radius is 3, because remember in our equation, the 9 is our r squared. So we plot our center, 0, 0. We go 3 up, down, left, and right. Connect the dots. That's our circle. Okay, so moving on to this next one. What you could first notice is that it has this inequality here. So that means we're going to do some shading, and our line is going to be dotted. So that's one thing to note. Next thing is we need to figure out what kind of shape is this. Well, we could look at our coefficients, because if we are looking, we see an addition sign, so that means it's either going to be a circle or a ellipse. And since our coefficients are different, that means this has to be an ellipse. Okay, so what I want you to do from here is get this in standard form, and then from there list out all the important features of an ellipse, graph it, and then check your work. Okay, so pause the video, find all of that, and then check your work with what I have. Okay, so this is what you should have for your ellipse. You need to get all your x's together, and then get your y's together, get everything else the 180 on the other side. You need to complete the square, so you're taking your b value, dividing it by 2, and you're squaring it to get 16, but on the other side you're doing this 4 times 16, so you're writing 64, and then same thing with the y's, you're taking your b, which is -6, dividing it by 2, squaring that to be 9, but you're actually adding a 9 times 25 to the other side, so 225. When you simplify that, this factors to 4 times x plus 4, and 4 comes from b value divided by 2. Then we get 25 times y minus 3 from our b value divided by 2 squared. It's greater than, when you simplify all of this, you get 100. In our standard equation, we need to get 1 on the other side, so we divide each side by 100, and we do that, we get x plus 4 squared over 25, and y minus 3 squared over 4. Then we just take the square root of the bottom and square this whole part there. So this is what we should get, making our x value 5, our y value 2, and our c value is 25 minus 4, our x squared minus our y squared equals our c squared, so we take the square root, we should get 4.6. And at this point, with your center at -4, 3, I graph all of those things, and then from there I see, oh, well, since it's longer in the x direction, I know I'm going to go 4.6 to the left and to the right of my center to get these 2 points for my foci. Okay, let's try this next one here. So first step is to figure out what this is. So we look, oh, we have an x squared, y squared. That would make it a circle, ellipse, or hyperbola. But since these are different, that would make it either an ellipse or a hyperbola. But since there's that minus sign there, that is what makes it a hyperbola. Okay, so same thing. Go through, list all the important parts of your hyperbola and graph it, and then check your work in a minute. Okay, so this is what your graph of your hyperbola should look like, and I've highlighted all the key parts that you should have. So to start off, we get our x's and y's together, we complete the square with our x's, and it factors to y times x minus 2 squared, and then we have our y's here, we do the same exact thing, so we have -25, still we factor that out, and we have a y plus 4 squared. Make sure when you factor out, you factor out of your b value as well for both of these. And then when you simplify everything on the right hand side, you get 225. Then you have to divide both sides by 1 to get it to be equal to 1. And then from there, you square root the denominators of both of those, and that is your graphing form. Okay, so your center is at your hk to -4, our x is 5, our y is 3. You get your c value by adding your rx squared plus our y squared, and so you should get 5.8 as your c value. Your vertex should be your in the x direction because x is positive, so it opens left or right. And so you get those 2 points. Then your foci, you start at your center and you're going to go 5.8 to the left and to the right. So when you subtract 5.8, you should get a -3.8 -4. And when you add 5.8, you should get 7.8 -4. Then to find your asymptotes, you have your point to -4, that's your center, that you know your asymptotes are going to go through. And the slope of 3/5, you can find that by going up 3 over 5. You know each of your asymptotes are going to go through the corners of your box that you drew. So that is your positive slope, so it's this asymptote. To find the other asymptote, it's -3 to the right 5, so -3/5 slope. Okay? So that is our hyperbola. So as we move on, let's look at this last problem here. So if we're looking, we have 1x and we have a y squared and a y. Since we only have one variable that's squared, that makes it a parabola. So what I would like you to do is find all of the missing pieces, all of our important parts of our parabola, and graph it. So pause the video, do all of that, and then check your work. Okay, so this is what your parabola should look like. Notice that it's sideways because our y value is the one that's being squared. So we get our 10 on the other side, and we leave a space for our completing the square. Excuse me. So then you divide your 6 by 2, and you square it, so you have 9. On the other side, you'll have a -18. And you add the 18 to the other side, so you would end up with -2 times y minus 3 squared plus 8, and that is all equal to x. So now remember your vertex, that is your HK. So it's 8, 3. Make sure you have those in the right order. Axis of symmetry is y equals 3. Your orientation, that's left. Your shape is narrow because our absolute value of a is greater than 1. For our x-intercept, you have to set your y equal to 0. For our y-intercept, you set your x equal to 0. So when you solve, you would get 0 and 1, or 0 and 5. And then for your p-value, that's 1 over 4a, and your a is -2, so you get your p-value of 1/8. To find your focus, you start at your vertex, 8, 3, and you're going to go to the left 1/8, your p-value. So that is that little dot right there. That is 7.9, 3. In your directrix, you're going to go 1/8 to the right. So you get that purple vertical line there. Okay? So if you notice, for our x-intercept, when I set my y equal to 0, I just used the original equation. It doesn't matter if you use your original equation or your graphing form of your equation, either one will work. But for my y-intercept, I saw that that would be a little bit easier to use the graphing form, so that's what I used. Either one would be perfectly okay. Alrighty, well, it looks like we're done, but I want to make one small note. If you noticed my mistake that I made in the video, please correct it and put like a squiggly circle around it with a smiley face next to it, next to the correction, okay? And if you do that, then you will get 1 extra point on your homework. So, yay! Alrighty, well, I hope this video is helpful, and I will see you in class.